All right, this will do. So what we've got here effectively is the two windows. We're going to follow along with the PONG clone in JavaScript at thoughtbot.com. And I mean, I know it's going to be a little bit longer of a video, but my plan is just to kind of type in the code, follow along, hit the run button, see what happens, have some errors together, and learn something along the way. So I really encourage you all to read this page yourself. Do this yourself. Don't just copy and paste it. Type it in there. There's some things that we might want to change, some things that we're definitely going to talk about. So to start, we need a little bit of HTML. So I'm going to move that over a little bit. We're just going to get started here. We don't actually need all of that HTML. What we want is just a heading, because the HTML is kind of built into the system. So I just want to put my name here, Steven, or actually let's call this Mr. Lowe because that's me. Mr. Lowe's awesome Pong clone. And then let's go ahead and give us an H. We're going to go 6. You can go all the way up to 6. And it'll be interesting because the H1 is larger than the H6. And then totally thanks to, and then let's go thoughtbot.com for the tutorial. All right, let's run that. And we can already see over here, we got this awesome Pong clone. So the next section, really what we're going to be doing is messing around in this JavaScript. So I'm moving these windows around. You might be able to move the windows around, you might not be able to, but we're definitely going to want to type into the JavaScript. The next section that we're going to do is this bit of code right there. So let's get typing. Var animate. So this is actually going to create a request animation frame invocation. It's basically going to be all like, hey, let's turn some things on, and what we need to turn on is the window dot request animation frame rate, or just frame, FRAME, and then these are like straight up and down lines. On a normal keyboard, you can find that key above the enter key. So it's the shift and then the button above the enter key. Then we got window dot web kit request. I really am. I kind of want to just type it all in. I know it's going to take some time. We're going to be here for a little bit. Feel free to watch this video in chunks. You know, get to where you're happy with it, and then 20 minutes or so at a time. That's kind of what we're expecting. Hopefully this video isn't too long, but I do, you know, want you guys to be able to watch this video multiple times if you feel like it. And yeah, type along. That's the real trick. So looks like we're almost done here. Function callback, and then this is the little function that we're about to create called callback. It's called, and in it we're going to do window.setTime and then callback, which is great. We're calling back our callback function, and we're doing that, it looks like, every 1000 divided by 60, either seconds or milliseconds. I'm not sure which. We could probably look it up, but I don't want to right now. Set timeout. And then callback. That's the name of the function we're calling back, and this is the time frame we're doing that in. And it looks like we're going to make it do the math, put a little semicolon on the end of that, and I feel good. I feel good about that. Let's run it. Nothing happens, which is fine. It's fine. So we're going to leave a little blank space, just one blank line in between each sort of section that we're bringing in. The request animation frame method is extremely useful. It functions a lot like set timeout, and then it'll call our callback at approximately 60 calls per second, or 60 frames per second. But makes it better than just using set timeout is the browser can perform optimizations on the call. For instance, if the tab isn't active, it'll stop making calls until it becomes active again. Huh, that's interesting. In order to perform rendering, we'll need to set up a canvas and grab the 2D context. So let's set up a canvas, shall we? So var canvas equals document dot create element, and then we're going to create a canvas. Now sometimes we actually get element by ID, but right now we're just going to create the canvas. Mr. Lowe thought that there should be a canvas, and so he spoke, and there was one. Okay, sorry, let's move on. Var width, this is going to be the width of the canvas. We're going to go ahead and set that at 400. These are going to be pixels. Var height, let's go ahead and set that to 600. And canvas dot width equals width, which makes sense. So we've created a variable called width and a variable called height right here, and then we are going to set the canvas width and the canvas height to that variable. So if we wanted to change the width and height, we could totally change that width and height, and we can also use that width and height in other formulas throughout the code here without having to check the canvas.width and the canvas.height. So height equals height, that's how you spell height. And then of course we're going to get the context, so var context equals, not minus, equals canvas dot get context, and then we're going to give this the 2D context. There we go. So that's that little section. Let's run it. Still nothing, that's fine. We get the page loads, we'll attach the canvas to the screen and call a step function using the animate method. Okay, so window.onload, and this is going to effectively, once the page loads, and it won't call it before it, won't call it after it, it'll just call it, and it'll call it automatically, which is nice, a function. And then this is the function that we are going to type in right here. So this is going to be document dot body dot append child canvas, and then we're going to do our animate and then step. So let's look at here, right here. We have document dot append child, or document body append child, and I've spelled document wrong. That's better. Append child, I've said that like 20 times. Canvas. So because up here in our document we don't have a canvas in our HTML, we are creating that canvas right here, and we are creating it instantaneously once the page loads right there. And then we're doing this animate function, which we have an animate function. It's up here, right? But we're doing a step, and we haven't defined a step yet, but the step function is going to be responsible for doing three things. First, it'll update all the objects. It'll the player's paddle, the computer paddle, and the ball. And next, it'll render those objects. And lastly, it'll use request animation frame to call the step function again. Okay, so we need to create a new little function here, and we're going to give ourselves a little blank line because it's in a new code section. So here's our var step, that's what we're doing. We're going to make step a new function, and that function's not going to take anything into its, like, there's not going to be any parameters or input to that function. It's just a function that will get called. And then we're going to have update. These are probably other functions that we're going to make pretty soon, I'll bet. A render and an animate, and then we're going to call animate step one more time. So looks like we're setting ourselves up here to get an update function and a render function. I would be amazed if we do not, in our next code section down here, create an update and a render function. To get something on the screen, let's implement update. So as a no op for our render function, we'll set the background of our game to, that's FF0FF. FF00FF, that's all the reds, none of the greens, and all of the blues. That's going to probably be like a pinky color. we're going to use the fill style and fill rect methods in the context here. Oh, look at that. We have our var update and our var render. So let's keep on trucking. We've got, I just feel like I'm typing at the bottom of the screen, you know. Let's see if I can make that a little taller so I don't feel so, whoa, not what I wanted. Feels so squished. There we go. Okay, that's good. All right, perfect. So we've got a var update. Oh, no, that's going to equal function. And then here we go our closing or opening closed parentheses. We're not passing anything into that function. And it looks like, oh, we need closing curly brackets on those. Do we need one there? Yeah, we need some closing curly brackets. All of our functions need closing curly brackets. This is a variable. It's ending that line. That's fine. Okay, glad I caught that now. Nothing's in the update right now, but I'm sure we will add things to the update soon. So we're going to go update render equals function. Spell function, right? Okay, perfect. And then it looks like we've got context dot fill style equals, and this is the fun part. We get to pick our own color. Hold on, let me just hit a bunch of blank space really quick. There we go. Okay, so we can give our fill style, and we're going to put it in quotes, a little hashtag in front of it, ff00ff. Beautiful in the line, and then context dot fill rect. And here we're going to make a rectangle. We're going to start it at the top left corner, which is 0, 0, and we're going to make it, well, the next one. So the rectangle looks like it's taking a top left corner, and then it's taking a width and a height. All right. And the things that we're going to put in here are the width and the height. So this rectangle is going to be the entire size of our canvas. Let's go ahead and run that. Run it. Run it. Something's wrong. Okay, I mean, it's not the end of the world. Let's find out what we did wrong. Let's see. Let's make this a little bit bigger if I can. Inspect. Console. Okay, here we go. We're in our console. We've got a document is undefined on line 41. Index. Well, this isn't really helpful. We've definitely got a problem. Failed to parse source map. That's definitely not going to help us. A cookie associated with it isn't secure. Nope. Okay, so let's just double check this really quick. We've got var animate. Pretty sure I spelled all of this right. A function update. Let me pull up the other window so that I can see it good too. So here we go. We've got our var update function right here, right there. And we've got the var render function, fill style, and fill rect, width and height. I mean, they've got a little bit more spacing in here, right there and right there. WITH, height, yep, that's right. We come up here, we got step, update, render, animate. And we got update, render, and animate. This happens sometimes, you know. We got things that should work. I mean, it says if we load the page, we should see something like this, and we don't see something like that. So that's why I'm, going back. We've got this window on load function. We've got document.append child canvas animate step, and over here we got window on load, document body, append child, canvas, animate step. Just not seeing it yet. We also have this section, var canvas, create element canvas, var width, var height, canvas width, canvas height, var context, get context. All those are the right colors. I feel like they're the right colors. We've got this little section. Now this section is formatted a little bit differently. It's got new lines after these little guys. We could do that here too. We can, we can do that just to make it a little bit easier for us to read here. Let's space that in, and space that in. The compiler isn't going to mind, or it shouldn't mind, having that on multiple lines, but let's double check here. So I'm seeing var animate, window.request animation frame, WebKit request animation frame, window.moz request animation frame. Okay, and that's interesting. Then there's this function, callback, window.setTimeout callback. Okay, all right. So I don't see anything wrong with this code per se. Let's clear a bunch of this text. Maybe it's just not happy with all the like weird text at the end of it. Oh, you know what? Let's put a semicolon there too. Let's run that. Still nothing. Okay, all right, fine, fine. That's really disappointing, but whatever. You know, it's not the end of the world. Let's do a crazy thing here. I just typed it all in, you know. Let's go ahead and just double check that I typed it all in properly. We're gonna copy this. We're gonna paste it. There shouldn't be any changes. Yeah, I didn't. Oh, you know what? Hold on. Nope. I mean, they put this closing semicolon or closing curly bracket and semicolon at the new line, but I didn't. Other than that, I didn't see any new changes. Let's come down to this section. These little guys, paste. I don't see any new changes there. We'll come down to the window on load, copy this, paste, no changes there. Copy the step function, paste, nope, no changes. I mean, they added a little bit of a space there and a little bit of a space there, but still not seeing any big changes here. Here's our var update and our var render. Let's just copy both of those at the same time. Var update and render. I didn't see anything change. You know, it happens sometimes. Let's undo that. Okay, so let's run it with my code now. And I wonder if I can keep going back. Let's find out where that problem was. I should have done this. Okay, so here we go. I've gone back to where it does not work. All right, we're going to copy and paste one thing at a time and try running it one at a time. So we're going to copy that right into here, paste that, run it. No change at all, right? It's not working. Okay, so now we're going to sometimes, because here's the thing, like when we copied and pasted, that means, and then it works, that means that we must have typed something in wrong. And okay, we had an error right here somewhere. So let's go back here. So guys, I'm not seeing where the error was though. Hold on, let me paste this one more time. Paste. Oh, you know what? I see it. I saw it. See that right there? Document. Yeah, that should be document. Bam. All right. That one little character right there, the E in the end. Oh, it happens. It happens, guys. But we fixed it. We found it, right? Like, I'm still going to type all my code. I still want you to type all your code. And if something's not right, something's not right. You know, we'll run it. It won't work. We'll double check it. But we got to know. We got to know. Like, sometimes you're just a little dyslexic, Stephen. And it happens. It happens. It's not the end of the world. Yeah, we're going to keep going. All right, we're going to keep going. So here we go. There's my code. There's my code. And there's that. And let me make sure that this is still recording properly. It is not recording properly. That's okay. Let's make this a little bit smaller. Move it over to there. Now it's recording properly. Yeah, that's better. Okay, so now I've got both of my windows open that I want open. Let's pull that a bit farther down. Now, we are at the point when we load the page, we see something like this. That's our little purple, well, pink. I'm going to say that's pink. It's probably magenta. I'm not an art teacher, but it's definitely all the red and all the blue. So now we need to add some paddles and the ball. So let's add our physical or our objects so we can render them to the screen. We'll create the paddle and give it an X and Y position, a width and a height. and both an x and a y speed, which we'll use later on. So here's our paddle function. So this is a new function. So we're going to go var, and it looks like he's got a capital P for his paddle. I don't really like having capital letters to start my naming stuff, so I'm just gonna not. Yeah, all of my other functions have lowercase letters, so I'm gonna do it with the lowercase, you know, and it's gonna take a couple of different parameters into this function. We're gonna have the x, the y, the width, and the height. Height. Oh, that's not a var. That's a function. Let's call it what it is. Function. There we go. Paddle. That's the name of the function. And inside of the function paddle, we have this word. It's called this. This is a magical JavaScript word. This refers to the object that is being played with. So it's like the paddle.x is this.x, and it's going to equal x, which is an interesting way of setting things up. Yeah, effectively we're creating a paddle with with these variables, and we're giving it these variables inside of it, and we're setting those up so that we can use them in the future. It's pretty nifty stuff. So we're going to have this dot x, and we're going to have this dot y, and we're going to have this dot width. And most of these things are going to equal, I mean, they're going to be what they say on the tin, right? So they're going to equal height, or they're going to equal width, depending on what it is. And we're also going to have a couple of variables that we're not going to get from the user or from the function that calls the paddle function. We're just going to have a x speed and a y speed. So normally when we think about paddles, it's not going to have the well, I mean, if the paddles are on the bottom of the screen, they're going to go left and right. And if they're on the sides of the screen, they're going to go up and down. But, you know, they don't normally move all the way around. So we wouldn't necessarily need the x and the y speed. We're going to use the underscore right there because that's how it's written here. You can find the underscore. It's by the minus sign or up by the 0 button on your keyboard. It's okay if you don't have, if you don't have an underscore, if you can't find it, you can also call it this dot y capital speed, like that kind of camel case. But we're going to do the underscore for now because that's what we want to do. Well, that's what it says to do in the tutorial, and that's we're going to try and follow that tutorial as much as we can so that we don't break things, or so that when we do break things, you know, we don't care. Interesting note here, they do not have a closing curly, or they have a closing curly bracket, but not a closing semicolon right there. But down here, they do have a closing semicolon, and that is because we have just declared this function. There's no, like, if this were a sentence in JavaScript, sentences that have equal signs in them need to be sort of like all on one line, or that equal sign right here needs to have that closing semicolon. And because we're just defining a function here, we're not defining the function and setting it equal to a variable all at once. We don't need to close that or add a ending semicolon to it. So now we do get a little bit interested here. We've got they've given it a capital P here. They're going to have a capital P there. I know I didn't want to. Let's go ahead and come back and make it a capital P so everything just matches. They're gonna do this a lot to me. So paddle dot prototype dot render. So prototype dot render equals function, and then we're gonna come in here with context dot fill style. And it looks like we're going to set this to a blue color. So that's no reds, no greens, and all the blues. That's great. And then we're also going to do a context. I'll bet it's a fill rect. Yeah, context dot fill rect equals, not the minus sign, the equal sign. And it's not an equal sign, it's a parenthesis. We're going to do a fill rect because a fill rect well, that makes a rectangle, and we give it a starting position, which is the top left corner of the rectangle, and then we give it a width and we give it a height. So this dot x, this dot y, this dot width, and this dot height. H-E-I-G-H-T. Yeah, that looks beautiful. And the cool thing here is that we get to use this magical word. Well, it's not magical word, but we get to use this this keyword this with the dot x, and that's referring to this dot x, and it's referring to that. But this paddle is only this paddle. We're going to have multiple paddles, and we'll be able to reuse, effectively call out or call these functions in this prototype when we want to make multiple paddles, and it'll know exactly which paddle it's dealing with, and it'll just work. It's really cool. So each paddle is controlled independently, one by the player and one by the computer AI. So let's create objects that represent them. So this is, I got a little ahead of myself. The X and Y coordinates are chosen to put the player at the bottom. The canvas's coordinate system's origin is the upper left-hand corner and the computer at the top. Okay, so we're going to have a function player, and in the player function, we're going to make a this.paddle equals new paddle. Hey! And then, of course, we're also going to have a function computer, right? And then this.paddle is going to equal another new paddle. So this gets to be fun. So let's go ahead and make our little function here, and we're going to have a player. That's beautiful. And this.paddle. And that is a lowercase p for paddle. Oh, that makes sense, see? Because we have now a lowercase p paddle here for our sort of local variable, and we have a capital P paddle over there. It's like a globally kind of thing. That's a good way to keep them apart. I'm happy with that. So that's going to equal, and this is where we make a new paddle with a capital D, or paddle with a capital P, and we have to give this some values. And now they're being really tricky here with their values. They're just giving it an X position and a Y position, so where it's going to start, the top left corner, and they're giving it a width and a height. Now that is interesting because these are effectively magic numbers. If we come back a little bit later, and we're not sure why we chose 175 or 580, or 50 or 10, like, why did we choose these things, and can we change them later on? So it might be something that we look at later, maybe making a paddle width and a paddle height and putting those variables in here, maybe even making a formula that we can use to decide where the center or where the paddle ought to be on the screen. Like if we want it at the bottom, maybe 20 pixels from the bottom, right? And then mostly in the center, we could use the width of it and get half of the width, and we'll deal with it later. For now, let's just put in some numbers, because why not? 175, that's your X. 580, that's the Y. And again, we start counting from the top left corner of the screen. So over here, effectively, this is 0, 0. This is X, which is the width, and 0, which is the height. And over here, this is the width and the height, and we've just named it that way. I mean, it's actually, if we go back and find out what the width and the height is, the width and the height is 400, 600. So the bottom corner all the way over here is 400, 600. You can't see it, it's all squished. All right, so coming back, a little bit of a detour right there, and we want this to be 50 wide and 10 high. And we'll end that. That's all we need in the function player right now, which is nice. And we need a function computer. Now this is a function is spelled with a C. Come on, guys. There we go. Computer. I always feel like I'm in an episode of Star Trek when I start talking to computer. Anyway, this dot paddle is also going to equal a new capital P paddle. And this one we're going to put at 175 again. But we're going to put it up near the top of the screen, which is at 10. 580 is near the bottom of the screen. And then same width and same height. So that makes sense. 175, we're going to go 10, we're going to go 50, we're going to go 10, and then there we go. That's all we need for the computer. Let's see what happens if we run this. So far, nothing, because we haven't asked it to draw a paddle. which is fine. Okay, so when we render, either the player or the computer will just render their paddles. In the future, we could extend this to render their scores as well, but right now we're not. So we do see a player.prototype.render function, this paddle.render, computer prototype render function, this paddle.render. So we don't have something that looks like that yet, but we do have a player prototype. No, we have a paddle prototype.render. Oh, okay. So let's go ahead and put that down below here, and we'll just go player.prototype, prototype.render, and this is going to be a function, and it's not going to take any arguments in here. Nothing goes in there. This dot paddle dot render. That's great. And then we also need a computer dot prototype dot render is also going to equal a function. And then this is going to be this dot probably paddle dot render, because it's the same thing, paddle dot render. Except we're just setting this up so that we can have a player and a computer. Maybe they're going to react differently, you know. The last object we need to create is the ball. Well, I want to run this and see if anything happens. You know, nothing's happening so far. Yeah, nothing's happening so far. That's all right, I guess. I feel like maybe something should be happening, but that's okay. We'll see. Maybe we just haven't, because there's a render function up here, you know, right here, and there's nothing happening here. You know, we're not calling these player prototypes or these functions at all. So maybe we'll call those a little bit later. So we do have a function ball. You know, I'm gonna add it to the end. As I'm looking at it, I've got like paddle.prototype.render, player.prototype.render, computer.prototype.render. I feel like I should keep all these rendery stuffs together, you know. And here we have a function player, a function computer. We're actually about to have a function.ball or a function ball, and then a ball.prototype. So, you know, maybe later I'll rearrange the code, just kind of move things around so that it's all like stuff.prototype.render and function stuff. But for now, I'm all right with it just being okay. It's a lowercase f, Stephen. Function. Typing is hard. Function capital ball. Here we go. And it looks like for our ball function, we are going to make that have an x and a y position. That's nice. Apparently, we don't care so much about, well, all that other stuff. For our, what was it for the, I feel like up here, right? Function paddle, which we had x and y and a width and a height. But the ball, we're not going to give it a width and a height. That's interesting. All right, that's okay. So this dot x is going to equal, all right, space equals x. We got an x, so we can use that. Dot y, probably going to equal y. All so far so good. This dot, okay, x speed. Now we do need an x and a y speed for the ball. That makes sense. It's going to move up and down and left and right. You know, apparently we're setting that speed up to start with at 0. This dot y speed is going to equal 3. So it's going to be basically not moving left or right, but it is going to move down 3. That's fine. And we're going to set a radius. So, oh yeah, that's the size of it. Dot radius, spell radius right, is equal to 5. Okay, so that's the size of our ball, which is fine. And we don't need it to change sizes at all, I guess. So now we have this ball dot prototype dot render function equals function. There we go. And this is going to be context dot begin. So the context means that we're starting to draw things, which is fine. I mean, our other prototype render didn't have that, didn't have this. Oh, you know what though? our other one, the paddle we did our context fill rect and context fill style. So this is just making sense. Okay, so we got a begin path. Okay, so we're starting the path, and then we got context dot arc. Okay, so an arc is a kind of circle, because we can draw a full circle, or we can draw any portion of the circle, and so arc is going to help us draw that circle. I'll bet. That's good news. So, and then this begin path is probably going to help us as well. So let's go into this dot x and this dot y and this dot radius. Okay, and then okay, so this is the x and the y position is the center of the circle that we are trying to make, or the arc that we are trying to describe. The radius is the radius. That's the distance from the center to the edge of the circle. I wonder if I could draw this out. I got a lot of weird like scrap paper in front of me, so don't worry too much. Okay, so here's the center, here's the radius, and here's the arc. So let's hope you can see this. This right here, that's the center of the circle. This little line, that's the radius of the circle. And if I were a better drawer, we could just extend that line all the way out, and that would be the, well, that would be edge of the circle, or the arc that we're trying to do. And I would bet that the last bit, this 2 times math.pi, is going to be how much of the circle we want to draw. And interestingly enough, to make a full circle, we need to go 2 times pi. I don't know why we don't just use tau, but whatever. I'm not having that political debate right now. So I haven't programmed tau to work in this, and all the math teachers are big fans of pi anyway. So math, does that say math? That says say math, but it's got a capital A. Math dot pi. And then this is false. I'm not sure what that false does. We can look it up in a little bit, though, if we are curious in a little bit. I don't think that it will be. So then we're going to have context dot fill style with a capital S style. And here we're going to set a color again. Now again, you can use any color you want. It looks like they're choosing to have none of the colors. So no red, no red, no green, and no blue. If you ask me, that should be black. So we're expecting to see a little black ball bouncing around. And then of course context dot fill, and let's see that. Well, let's just keep going, shall we? Yeah, let's go one little farther bit, because right now, I mean, if we run this, still nothing happens. Nothing happens. That's because we haven't done this little bit yet. So we have to add, we have to build our objects, and we have to update the render function. So we don't have a new player, and we don't have any of these things. We've set them up, but we haven't made them, right? So here we can have a var player, and that can equal a new player. And the new player is going to come right up into here, function player. This is a new paddle, right? And so it's going to come right up to here and make a paddle. Yeah, like we're building some stuff, you know, before we can actually make it up here. It's a kind of chicken and egg situation, but now we've got the player, and we can also have a computer, and this is going to be a new computer. Q-U-T-R, there we go. And then we can also have a ball. And note here too, the lowercase and the uppercases, new ball. We've created these things with constructors, really, functions that create things. And we've got a variable here with a lowercase name. So now we can go into var render. Now we have a var render, so we have to come up here to find our var render. Here we go, var render equals function, right? It's right here, it's right here. If we were to add this code to the bottom of our code here, it wouldn't work because we've got 2 var renders at that point. We don't want that. So we're just going to add the codes that aren't here, the lines of code that aren't here already. We already have a context fill. We have a context fill. We also have the context fill rect, and we have that context fill rect. We don't have a player, computer, or ball. So let's add that. Player dot render, and then computer dot render, oh, and a ball dot render. And here too, note that we are using the lowercase letters, right? Which means that we are getting this player, that computer, and this ball. So now when we run this, hopefully, yay! I got a paddle up at the top. I got a paddle there. Let's run it one more time. I got, well, hold on. I'm not seeing a ball here. Let's, maybe I just can't see the ball. Ball.render? Maybe I spelled ball.render wrong. Where's my render? Ball.render, that looks right. Here's my variable ball, that's my ball up here. We reload the page, we should see a beautiful black circle there. And I'm not seeing a beautiful black circle. Are you guys seeing a beautiful black circle here? Right in the middle? I'm not seeing that. Well, let's look at this code a little bit more closely. It's getting an X and a Y. Oh, you know what? We're not giving it. It's expecting an X and a Y. And did I just skip that portion here? Where we have a new ball? Oh, look, I did. I mean, there's a 200 and a 300 there, and I'm not passing in any information at all. My gosh, I'm blind or something. So 200 and 300, and now I'll bet when we run this, we have our little ball there. There it is. I see it. It's all happy to be there and stuff. Little black dot. That's great. Okay, so we run into problems. It's not the end of the world. You know, we read the code. We double check the tutorial here. We know we can do this. This was a little hint too. I mean, right, when our function ball, right, this is a new ball. This is actually literally calling this function right here, and like it's expecting an X and a Y position, and we didn't have an X and a Y position, so it was just like, well, all right, I'll put it nowhere. And nowhere happened to be not on the screen. So, all right, so now we get to animate things. So to animate things, oh, guys, according to this progress bar, we are about halfway done. I am pumped. We've only been going for 40 minutes. That means another 40 minutes to go. It's a good thing I verified my YouTube account and I can upload longer than 15-minute videos. But oh boy, howdy, that's a long video. You should watch this in parts. In fact, when you get to this point, do me a favor. Send me an email with a link to your saved file. Oh, let's save it. There we go. We saved it. Send me this link, and in the email, right, the secret, super secret code is halfway done. Hooray! All right, just send me send me an email with a link and tell me that you're halfway done and say hooray, and then I'll know that you made it this far into the video. And I'll get you points in your grades or whatever. You're not doing this for the grade. You're doing this for the fun of it because it's so much fun. I'm having a blast. I hope you're having a blast. Everybody's having a blast. All right. So, where were we? Oh, animation. Let's animate stuff, dudes. Let's animate. So, to do this, we need to change the update from a no-op, which is a function with nothing happening, to do stuff, ball.update. So if we come up here into our update function, here's our var update. For me, it's on line 24. Here we go. Var, oh, whoa, that was bad. Okay, so var dot update, not var dot update, var update equals function, and here we're gonna have a ball dot update. Update. There we go. And now, see, this is great, but we have to actually create a update function, right? So we have this prototype render, Now we need a ball prototype update. So let's come on down here, and we're gonna go ball, capital B ball, prototype dot, that's not right, prototype, there we go, update, and better, equals function with a C this time, thank you, and this dot x, and we're going to go plus equals this dot x underscore speed. This is an interesting thing mathematically. I'll break it down, don't you worry. So we're going to tab that in just a little bit too. it just looks better when it's tabbed in. This dot y is going to do the same thing. Plus equals, nope, that's equals plus. Plus equals, that's what we want. This dot y underscore speed. Okay, so let's break down this. This one line here, right? This dot x is plus equals. That means it's getting the value of this dot x plus, or this dot x underscore speed added to it. Yeah. And it's plus equaling it. So it's just continuing to add to it, right? It takes the value and maybe it adds 5, and now it's the value plus 5. If x was 10, plus equals 5 would be 15, and then 15 would be the new value of x, and plus equals 5 would be 20. And it just goes like that. It's a kind of a, not lazy, but you could also say the same thing would also equal this dot x plus this dot x plus dots, or this dot x underscore speed, all right? These two lines right here, this dot x and this dot y, except for the dot x and the dot y thing, are the same thing, programmatically speaking. This is just a little bit of a shorthand. If there's one thing I know about programmers, it's that we will just do things. If it saves a half a second, we will spend 2 hours working on it to save a half a second, because that half a second eventually will add up. And somebody a long time ago decided to spend some time and make plus equals a thing. So it's not something you're going to run into in your normal math class, but it is something that you run into in your programming class, plus equals. Okay, so and then this is actually interesting too, because we have a speed, right? And now our value, the position of the ball, is being updated by the speed. So every time this happens, every frame, effectively, the ball's going to look like it's moving. So if we scroll down here, we can see this happy little GIF, I don't care how you say it. It's animated right now. So if we run this, we should also see our animation happening. Let's run this. And we can see it's ours going a little bit quicker, but it's definitely moving, which is fantastic news. We have a moving ball on the screen. I'm just super pumped about this. All right. So since the paddles are stationary, we can't make the paddles move, and we can make the ball bounce back and forth between them by modifying our update and check to see if the ball hits the left and the right hand sides or the top and the bottom. We also need to pass both of the paddles into the update method. Okay, so what we're going to do here is we can make the ball bounce back and forth between them by modifying our update and checking to see if it hits the left hand side or the right hand side or the top and the bottom. Okay, so here's our update section. We have one of those. We've got one of those already, and we want to put this code, this new code, into it. So here's our update, right? Here's our ball.update, and we've got a player paddle and a computer paddle as well. Now our update ball thing, hold on a second, it didn't have anything in here, right? So by adding stuff into this ball.update, here we go, by adding parameters to this function, by passing parameters into the function, that means we're going to have to update our function to deal with those parameters, but we can handle that. So we're going to take our player.paddle and our computer.paddle, and we're going to do things either to those or with those, right? And so we're going back down here to our ball.prototype.update function, which is right here. Now we do need to accept those new parameters, those new things that we passed through, those variables, right? They have to show up. So paddle, now we can give the paddle the variables new names, which make it easier for us to understand what is happening here, and not having to refer constantly to those global variables of, you know, computer.paddle and player.paddle. So we've named effectively player.paddle paddle1 and computer.paddle paddle2. So now we can do things down in here, and it looks like this function is getting quite big. This is all in that same function, all right? So that ball updating is really doing a lot. We're going to break it down. Don't you worry. So this first section, we are still updating the position based on its speed and its its speed, the x and the y. Next, we are taking the top and the bottom of the ball. We're getting the top x and the top y and the bottom x and the bottom y. we are building a kind of block around it, right? If this is our ball, that's the X and the Y right now, okay? And then this would be the top X right up here, and this would be the bottom X right here. This would be the top Y over here, and this would be the bottom Y over here, which is a interesting way of thinking about that. Top Y and bottom Y. I would think of more like, but what we are literally doing here in these 4 lines, as far as I can tell right now, is building a kind of like hitbox around that circle, okay? Which is fine. Let's go ahead and do that. So we're going to make a var top x underscore x equals this dot x minus 5. And again, here's the thing, right? We're using 5. Why are we using 5? What happens later if we want the ball to be a different size, right? Here's our radius. It's 5, right? Why aren't we using our this dot radius? You know, like, why aren't we using the this dot radius? Because if we change the size of the ball, then minus 5 doesn't work anymore. And so guess what? I'm going to put in this dot radius right here. All right, I'm going off script. It's better this way because we've got it defined up here, right? We do not have to remember these things. This is why we were having the computer remember these things for us. We're not, and this is more easy to understand, right? The top, underscore x, that's a variable name, not top minus x. The top x, right, that is the x minus the radius, which is the top, right? Yeah, which is just the top. I don't need top x, it's just the top. This is the top. And then we have the top y, which is actually the left side. Yeah, the left side. So var, we're going to call this left, and it's going to be this dot y minus, and we're not going to do minus 5 here. We're going to do this dot radius. Because if we decide to change the size of that ball, we want it to change with the size of the ball. And then, of course, we're going to go var bottom. And I get bottom. Why? Just makes no sense. Bottom does make sense, though. It's the bottom of the ball. And that's going to be equals this dot x. And that's going to be plus this dot radius. And again, we're using the dot radius here because the circle is a radius. And that's where the bottom of it is. And then we can have the right side as well. Var right equals this dot y, and it's going to be plus this dot radius. And it's plus because, again, the way that the stuff works, if the top left corner, the top left corner is the normally the center, well, the starting spot of the canvas. So that is 0, 0 here. And it gets bigger as the numbers go out this way. They get bigger. And as they go down, they get bigger. All those numbers are positives. So, it's a little bit different than graphing in math class. But anyway, things get bigger to the right and they get bigger to the down. And that is why the right is adding the radius and the down is adding the radius. Hold on 1 second, though. The bottom should be the x should be left and right. So this should be a y, and this should be a x, and this should be a y, and that should be an x. So the top should be the y value moving, and the bottom should be the y value moving. This makes sense. The left should be the x value, and the left should be the x value. Much better. Okay. I'm sure it would have all worked out in the end, but I think this makes more sense. So now we are going to, in this section right here, we're going to have an if codes. So we're going to have an if, and we're going to check to see if this is true, and then that means that it's hitting the wall. It's hitting the left wall. Why did we go through this dot x minus 5? Why is not this dot x minus 5 top x? Why create a variable and then not use it? Hold up a second, man. Like, hold up, they went through all the trouble to create top X, right? And then they're not using it. This is beautiful. You know what? I went through all the trouble of making those variables. I'm going to use them. I'm going to use them. So my code right now officially is going to look different than this code. Yeah, unless I'm reading this incredibly wrong, but I don't think that I am. So if, here we go, and this is checking the X spots. So if the left, yeah, is less than 0, yeah, if the left is less than 0, then that means I'm going to add a little comment here. They've added a comment. They've added a comment. I can add a comment. Hitting left wall. And what we're going to do then is this dot x equals 5. We're just going to not be in the wall anymore. And this is going to be fun too. This dot x underscore speed is going to equal, this is a minus, right? Which is not the same as subtracting. This is like a negative 1 times. We're inverting it. If it were a positive 17, it is now a negative 17. Well, actually, if it hits the wall, it's a negative speed because it's going to the left. And then it'll be suddenly a positive speed. So, but that's fine. We're just going to go minus this dot x underscore speed. All right, so that's what happens if it hits a wall. Otherwise, we can check to see if it hits, yeah, if it hits the left wall, we should do that. Else, if it hits the right wall, we should do that. And then we won't need anything special, like if it's in the middle of the screen, we can just let it do its normal thing. So we can have an else if right here, else if. And we use an else if because we don't need to check it. Well, we do want to check it, but we want, yeah, you know what, we're going to use an else if. Yeah, we'll be fine here. So if we're going to go, and again, we're going to just go right. Right is greater than, and now see here, they've got 400. We should actually use the variables that we've created. We know how wide the screen is, right? It's width wide. That's how wide it is. Width. Yeah, look, up here. Width, right there. They're using the number 400. We are not going to do that. We are going to use our variables. If we decide that the width should be 17, the width is 17, and I'm not going to remember everywhere I put the 400 number. That's what variables are for. Okay, so that's just me being a little crazy. We're good here. So let's go this dot x equals, and here again we are not going to do 395. We're going to do width minus this dot radius, because our radius might change and the width might change, and so the position of our ball is a math problem, right? They literally did the width, which is 400, minus the radius, which is 5. So 400 minus 5 is 395, but we don't want to hard code that in there. We don't want to. We're going to, because what if our radius is different? What if our width is suddenly only 100, right? And then it gets stuck in this infinite loop where the ball can't get back. We don't want that. We don't want that. So we're going to let the computer do the math when the computer can do the math. I think we can do that. You know what? Yeah, we can totally do that. So there's our width, and if it is over there, we do need to do this same thing that we did with our speed before. So this dot x underscore speed is going to equal a minus this dot x underscore speed. And that'll just flip it to go the other way, right? So, yay! That's what happens if it hits the left wall. This is, let's put a little comment in here, hitting the right wall. All right, if it hits the wall, we just kind of want it to bounce right back down. No worries at all. That's interesting. This next section, a point was scored. That means that it hit the top or the bottom, right? If it hit the top or if it hit the bottom, I guess a point was scored, which is fine with me. Okay, that's fine. That's a point. But whose point? right? This dot y is less than 0, or this dot y is greater than 600. That 0 should be 0. That's the top. That's never going to change. No matter how big our height is fine. The 600 here, we're going to put height in there. We're going to use the height because we want the height. We want the height. This is also not checking, like it doesn't care who's scoring the point, right? So I'm not going to, like, I don't like that. Like, there's no score here. We'll have to come back to that score and add a score, but we'll do it now. We'll just do this. This dot y is less than 0. Interesting here too, right? Like, this could have been. Well, no, this is different than that, right? And so that's why. But here, it's just setting it right back effectively to the center of the screen again, which is fine, So we can use the or there. Okay, so it's 0 if it's less than 0. These two up and down bars right here, that's or in JavaScript. We've seen those before, all the way up here. Var animate window, or. That's because if I were going to guess, this is one browser, that's another browser, this is a different browser. These are 3 different browsers depending on what browser it is you're using. But that would be my guess. I don't really know that. I'm just looking here at the Moz request and the WebKit request. I think WebKit is a Chrome thing and the Moz request is a Mozilla, a Firefox thing. But I don't know. So anyway, here's the or. That means that if y is less than 0, i.e. at the top, or this dot y is greater than, and again, they've got 600 here. We are not going to use 600. We are going to use height, H-E-I-G-H-T. And if it is greater than the height, that means that it's hit the bottom. So point. Add score stuff later, I guess. So here we go. Where's my thing? There we go. On the next line, they are going to set the speed back to 0 for the x speed, and the y speed is going to go right back to 3. So they're effectively resetting the game. Interesting. Right up here, when we are making our original ball, we're making it with 200 and 300, right? Which is fine. And then we're setting the original speeds to 0 and 3, which are, again, fine. I'm okay, I guess. We haven't made a variable for the original speed. So this dot x underscore speed, that's speed equals 0. And this dot y underscore speed equals 3. I'm fine with this. But this dot x equals 200 thing. I don't know that I'm happy about 200. This, you know what? I'm going to go width divided by 2. I just want it to be in the center and let the math be the math, right? This dot y should be height divided by 2. You know, let's let the computer do the math. If it's 200 and 300, let you know what? I'm going to do it here too. I want it to start out in the center. I'm just going to make it figure out what the center is. Width divided by 2. And height divided by 2. There we go. That's, you know what, let's run this. Let's move this over a little bit. Move that down. Okay, you know what? Oh, check that out. Check that out. I mean, that is working. That's hitting the bottom and it's going back to the top. I'm super pumped about that. Yeah, okay, great. So, I don't think I'm done though. That's this. We've got this. Okay, now we've got this top. If top y. Oh, we finally use a top y. What is top y? Top y is this dot y minus 5. That's the top of the ball. Okay. Is greater than 300. If it's on the bottom half of the screen. Okay. If it's on the bottom half of the screen, we're going to do this. And then if it's on the top half of the screen, we're going to do this. Interesting that we have 2 ifs, right? Right here, if, and another if. we're using this top y. Let's understand what's happening here in this code, because this code goes on for a while. So we've got top y, which is the top of the ball is greater than the paddle.y plus the paddle height. The top of the ball is equal, okay, and the bottom y is greater than the paddle y, because we're on the bottom of the screen? Yeah, that's the bottom of the screen. Okay, and the top x is less than the paddle.x plus paddle.width. Okay, and the bottom x, interesting, is greater than the paddle x. Then we want to, that's going to be hitting the player's paddle. So apparently the player's paddle is on the bottom here. Let me see if I can draw some of this stuff out. I don't have a blank piece of paper. I have this. It's beautiful. Let's see if we can see things in this. Can you see this? Let me just double check really quick. Can you see this? Yeah, you can kind of see that. Okay, great. I'm going to make a little demonstration of what this code is actually talking about. And we are at the 1 hour mark. You guys just pushing through, just keep on going. Okay, so what we've got is if top y is greater than 300. Okay, that's fine. If top y is less than, so first we know that we're at the bottom of the screen. So I'm going to draw my paddle. Okay, this is my paddle dot x and paddle dot y. Hold on a second. Y. Okay, so this corner right here, top left corner, is paddle x, paddle y. Let me make sure that you can see that. Paddle x, paddle y, top left corner. That might just be straight up backwards, but that's looking good for me right now. So that's the top left corner is paddle x and paddle y. And then over here, we have the width of this is paddle.width. X plus paddle width. Yeah, well, and actually that's paddle 1, and that's paddle 1, and that's paddle 1, and that's paddle width. Okay, that's fine. And then this over here is going to be paddle y plus paddle height. All right, so let me make sure you can see this again. So the height of this is that's the y value right here, right? Top left corner. The y value plus the height is this corner down here. Okay, and we are checking to see this bit of code right here says that if the top of the ball is less than this spot, which would be this is less than, right? So if it's above the bottom of the ball and greater than, sorry, if the ball is between, right, the bottom of the paddle and the top of the paddle, effectively, that's what this section right here is saying. If the y value of the ball is between the top and bottom of the paddle. And the next section is going to be a similar thing for the x value of the ball and the paddle x value and the paddle width. All right? So effectively, we're trying to see if the paddle is touching the ball. Yeah, it's that simple. I mean, it's kind of complicated because we're trying to make bounding boxes, right? We have to describe this stuff mathematically. And to do that, it might get a little confusing sometimes, but we know that we can figure this out. So the first bit, let's translate this into what we've got. And also, like, I get that it's only going to check if it's on the bottom, right? That'll make it a little quicker. So we can do that. We can come over here and we can go if top y, we actually just called top, is greater than 300, right? But we can't use 300. We need to use height divided by 2 because our height might change. Height divided by 2, okay, if it's on the bottom half of the screen, right? It's an easy check, and then we don't have to check at all. We're checking one of them or the other of them, though. I don't know why. I feel like this big if right here and this big else right here with these little if and this little if nested inside of those. I feel like that's supposed to like make it a little bit quicker, and it probably does. Yeah, but whatever. So here we go. We have another if. So we're going to go if. And now we have the top is less than paddle 1 dot y plus paddle 1 dot height. Okay. And we have to put that in parentheses because that is a compound, thing. We're not seeing if top is less than paddle y. No, we're seeing if top is less than paddle y plus paddle height. And we can't just look at the paddle height because the paddle height is going to be like 10, but the actual location of the paddle height is going to be like, 5 or so from the bottom, right? Which is a thing. So we've got the paddle height, and we're using the and here. So if this is true, and this next section is true, and this next section is true, and this next section is true. So effectively, we need all 4 of these to be true, right? That's where we care about it. So that's section 1. It's on the bottom of the paddle. Now we need to check the top of the paddle. So this one is going to be bottom is greater than paddle 1 dot y. All right, and we have top x, which let's just like think about this for a second. This is the paddle x plus the width, so this is the right side. So this is right is less than paddle 1 dot x plus, oh, we're going to need our parentheses here. There we go. Paddle 1 dot height, no, width. All right. And then, and we can see if it's on the left side. Left, top x, bottom x. That's just, it's a weird way to write things, and I'm not faulting the guy for it. It makes sense. It's confusing, but it makes sense. Is going to be greater than, paddle 1 dot x. And if all of that is true, that's what all those ands mean. If all of those 4 things, actually let's see if we can ship this up a little bit, straighten it, so that we can see all of these things in a little bit beautifuler way of seeing it. There's our bottom, there's our left. All right, so here we go. We've got our bottom, our top, our bottom, and our right and our left. All right, all of those things should probably still work. It's going to be on this little thing. And if that's true, if we've hit the player paddle, right, make it hit player, hit the player paddle, then this dot y speed is going to equal, and now here they've done it, -3. Okay, so which is okay. The up and down, if we want that to be the speed, we're going to just go for it now. Okay, so the -3 though, because we want it to go up, and the this dot x speed is going to be plus equal Oh, okay. So we're gonna put a little like English on it, a little spin on the ball. We're gonna move the ball. We're gonna give it an x value that's as fast as the x value of the paddle, which I think is cute. I think that's a great idea. So paddle 1 dot x speed divided by 2. So it's going to be half as fast, right? That means if our paddle is currently moving at 10, then the ball is going to get about half as much of that. It's going to move 5. And if our paddle is not moving at all, then we're not going to really adjust, because 0 divided by 2, we can divide 0 by things, but we can't divide 0. We can't divide by 0. Yeah. So if the paddle's not moving at all, it'll just keep having the same speed, which is fine. And then of course we're going to do a thing where we this dot y plus equals this dot y underscore speed. And we're doing that just to allow it to immediately bounce back out, right? We're not going to wait for it to get rendered again. We don't want it to get accidentally caught in that if statement. So we're just right on out. And now we can do a similar thing with this else. So make sure we're at the same level. Mine is highlighting it. How nice is that? See that little underscore right there and that little highlight there. So we can have an else. We're going to come in here. Okay, there's my else. Yep. And then here we go. We're if. And it's going to look a lot like this top portion, but it's going to be for the top paddle. So it's paddle number 2. And our tops and our bottoms are going to be a little bit reversed. They ought to be a little bit reversed, but I don't think that they are. If I look at this right, this is top Y being less than paddle 1 plus the height. And this is top Y being less than paddle 1 plus the height. You know, I'm just gonna go with it, and we'll see if it looks funny, because maybe I've just been coding too long, and I don't know anymore. But that seems a little reversed. But you know what? Top Y is going to be top. It's going to be less than. I don't want to copy and paste, but I told myself I wouldn't copy and paste because I want you guys to experience this. So paddle Y plus, that's going to be paddle 2 dot height, HEI, GHT. There we go. And we're going to give ourselves some and symbols, and we're going to go down a line. And here we're going to tab right in, and we're going to go bottom, and it's going to be greater than, perfect, paddle 2 dot y, and then we're going to go right, and this is going to be less than paddle 2 dot x plus paddle 2 dot height, no, width, width, and we're going to go left, which is going to be just greater than paddle 2 dot x. And hopefully this is what we want. Let's bring that up there, bring that over there, shove that down there. I'm looking at this because I looked back up here to see, and this guy is white. That white thing means to me that I have misspelled something. And in fact, I've got 2 L's and only 1 D, so let's make that a D. I'm better now. All right. Yay for colors. So it looks like this has very similar in this if statement. This code and that code are practically the same thing. In fact, the only difference, this is nifty, the only difference is right here. This is a -3 versus a +3, which tells me, which honestly it tells me that this, well, it's the same. So whatever. We're gonna, yeah, that's already tabbed in. Yeah, so this dot y underscore speed is now going to equal a +3, and then this dot x underscore speed is going to equal plus equals paddle. Oh, this is different too. Paddle 2. Oh no, I need a parenthesis here because we're doing some math. Paddle 2 dot x underscore speed divided by 2. All right, that's good. And then we're going to go with this dot y and plus equals, not equals plus, plus equals. You can do equals plus, but they're different in very strange ways. Like if you do plus equals, then it does the math before it assigns the value. If you do equals plus, it does the math after it assigns a new value. Or it doesn't return the thing. So it still increments the variable, but you're going to get the answer before it increments the variable, which isn't always what we want. So we got to do plus equals, not equals plus. So this dot y underscore speed, beautiful, and that should be that's that section. Okay, so that's the collision detection. If we run this, our ball should probably start bouncing up and down. Let's hope. Let's just hope. Oh, hold on. Woo! Yes. And from the top here, yes. I'm pumped, guys. I'm just super pumped. Very excited. Our ball is bouncing back and forth, and I just cannot be happier. Okay, so the collision detection happening here, pretty standard. Axis aligned bounding boxes, or AABBs. You'll notice the code that if the paddle is moving when it hits the ball, the X speed is added to the ball. This calls it to move faster or slower, depending on the direction of the ball and the direction of the paddle. Yeah, now this would be great, but we can't control anything yet, so we need to be able to add controls. We're so close, so close. We're going to add in controls so the player can update the position of their paddle. We're going to do this by adding a keys down object to keep track of which key is pressed. Okay, so here we go, var keys down. Oh yeah, keys down. I love me some like controlling thing. Oh, var. Guys, var is spelled with an A, not an E. Var, there we go, key down. And then that's apparently not doing anything, but that's fine. I'm sure we'll do stuff with it soon. So window dot add event listener. Event listeners are how we can get the computer to tell us that things are happening. Key down. Key down. Okay, that's better. And then the function event, we're going to pass that event in right here. And this is going to be keys down. Spelling is hard sometimes. Here we're using a square bracket. The square bracket is the same key as the curly bracket. You just don't hit the shift button. Event dot key code. And then this is going to equal true. All right, that's fine. That's going to have a thing there. That looks fine to me. Yeah. Okay, great. We need another one of those. That's for our key down. We're going to have another one for key up. And it's going to delete that key from the key code, which is fine. Looks like we're actually creating a what's that called? It's a variable filled with variables. It's like a list of variables. It's like an array. That square bracket normally denotes some sort of an array. But anyway, window dot add event capital listener key up. Function event. Boom. We're going to have a delete. Oh yeah, this makes sense. We're kind of adding something to the array, or more likely putting a true value into a particular spot in the array, and then we're deleting that value from the array. So that's fine. Keys down. Oh yeah, okay. So we have a keys down array, and that's cute. Okay, great. Square bracket event dot key code. There we go. And it looks like we need to close that with a parenthesis and a semicolon. Okay, so now the update method of the player can update the position of its paddle depending on which key is pressed. So var update, let's go to var update, which is probably up here somewhere. Hold on a second. Var update function. Ah, var update function. Found it right here. Okay, we've already got ball, update, player, paddle, computer, paddle. Now, when we think about the play like area, why did they add this on top versus below? And that's because we want the player to update and then to check the ball. And that's why. Because if the ball is here, but the player had moved to here, but the ball got moved first, right? Then we just miss it. And that's annoying. So we're going to move the paddle first and then check. And that makes sense. Oh, say, okay. So we're going to go player dot update, update. That's better. Great. Now we need a player update function, and let's see if we've got a player prototype update. And we have a ball prototype update, but no player prototype update. So we got some options, but let's go ahead and just add it to the end. So player dot prototype dot update equals. Oh, yeah, that's right. That was right. Function. Okay, and now here we're going to have a loop. So what's happening here, right, is that we're going to go for var keys, right? So the key in, keys down. So for every key in, key down, we have a value equals the number key, right? And wow, if the value of that number key equals 37, that's a left arrow. So we're going to move left. Else, we do an else if, because if this is true, we don't need to check anymore. It's a 37, so we can just go to the next one. But if it's not true, we can check this. And if this is true, if it equals 39, then it's a right arrow. And so we move it to the right. And we're just straight up dot move, right? We're not giving it any speed at all. We're just like, if it's down, it's going. And then otherwise, we're not moving it at all. Which is pretty straightforward, honestly. So we're gonna go for, make a little for loop here, var, call it key, in, keys, down, capital D, down, oh, lowercase key, oh, wow, spelling, down. Okay, and then we're going to have a new var, value equals number, lowercase u, number, and then key. All right, that's great. Yeah, if the value equals 37, and again, that's kind of just a magic number right there. That is the value of the arrow key for the left arrow key, right? Left arrow key. But that's what the value is of that left arrow key. Then we're going to go this dot paddle move, and we're going to go -4 from where it's at, and we're not going to change the up and down at all. And then we're going to do an else if, and it's an else if because if that first one is true, then the second one can't be true, right? So we don't need to check it. Value double equals, and we use 2 equal signs here because we're checking to see if they are the same thing. If we use 1 equal sign, we're effectively assigning it value is now 39, and that's always true, and that's not what we want. So this is going to be the right arrow. If you wanted to use the WASD keys, you would have to find the value of those keys, which we could do. We'll show you how to do that in another video, but paddle.move, and then of course we're going to give this a +4 and 0, and that works. And then we'll do an else, move nothing. Now that's interesting. Why would we need to move nothing? Maybe it's going to move every time. Maybe I don't know. I'm kind of tempted to see if we can just leave that out, but I'm not. I'm going to put it in there because it's in there, right? So this dot paddle dot move. I'm going to make a little comment though. 0, 0. Why Why is this here? I don't know. I could probably get rid of it. Now, we just asked this paddle.move, and we don't have a paddle.move. Like, it's not here, right? Our paddle prototype, nope, paddle. We have a paddle prototype render. We do not have we don't have a paddle prototype move. So we have to add a paddle prototype move down here. So paddle dot prototype dot move equals function. Oh, and we're going to need an x and a y value, which is fine, I guess. And here we go. We're going to get this dot x. This is a lot for a thing that's not ever moving up and down. We sure have a lot of up and down code in here, but whatever. Now we're going to take the x value and we're going to add it to the previous x value. We're going to take the y value and we're going to add it to the previous y value. We're going to take this dot x dot speed. Now we do have a speed for our paddle, so that makes sense. We're not using. Do we have a ball dot prototype move? Because it feels like we're doing a lot. That's an update, right? Like, whatever. It feels like some of this is kind of repeating itself, but such is life, right? Hopefully we can use this prototype move thing for the computer AI. Yeah, I don't know why we have the up and down though. So this dot x, I should just stop talking and type. Speed equals x, and this dot y speed underscore speed equals y. What? That y, the speed is x now, and the y is the speed of the y as well. Okay. All right, that's a strange thing to do. I don't know why it's giving it a speed at all. It seems like we're just updating its position, but maybe things will happen differently. Maybe if I tap it once, it'll just keep going. That'd be weird. If this dot x is less than 0, effectively, if it's all the way to the left of the screen, let's change that little comment. Left of screen, stop moving. Stop moving left. And here we go. This dot x equals 0, which is the left, and then this dot x underscore speed equals 0, which means that it isn't going to just coast. I mean, does it coast? I don't know. And then we have an else if. Else if, probably going to check the right side of the screen. And in fact, that is what is happening right here. They've hard-coded the 400 in there instead of the width, but we know better. We're going to use the width. So if this dot x in plus this dot width, see, there they are. They're not using 10 there, right? Like, well, it's actually 50. They're not using 50. It's greater than. And now see, for parentheses' sake, let's put some parentheses in here. If they show up on the other side, we would put parentheses there. Let's put them on this side too then. All right, come on. Yeah, I mean, order of operations says that we don't really have to, but let's just make it. And then this is just going to be width, because that's the width of the screen, and that is what we want to check, regardless of what the width of the screen is. So this is right side. Stop moving. All right, so here we go. This dot x equals, yeah, we're going to go width minus this dot width. See, why do they have a variable for one and not a variable for the other? Just doesn't make any sense at all. This dot x underscore speed is going to equal 0. Again, that's, I guess we can coast. And that is the end of the moving. Let's see if we can run that and see. Well, I kind of want to see if I can move my thingy. Hold on, I can move. I can move, guys. Oh, I can move. And look at this. Yeah, I'm moving. I'm a mover. All right, cool. Well, I'm happy about that. I can move. The computer isn't doing much. He's very, very bad at what he does right now. But we can control our paddle and the ball bounce around accordingly. However, the computer's not very good. So we need to do some really simple AI, and really simple AI means just let the computer cheat. All right. For this project, the computer will just try its best to position itself according to the center of the ball. We'll get the computer player max speed. Oh, maybe there we go. It'll occasionally score a point. We'll need to alter the main update function as well to update the computer player. So, okay, back to the update function. That's the var update all the way up here. Now, it looks like they are doing player update, then computer update, and then the ball update. Okay, and so we are giving the computer the entire ball. Like, the computer is totally cheating. Computer, and then update, and then we'll just pass it in the ball, which is got a lot of information. Yeah, it's got a lot of information, and it's not even like all that Y stuff, like all of this stuff down here to be able to move up and down. Like, we're not moving up and down, but it's got all the code for us to move up and down. Whatever. That's fine. Where's this? This is good. This is good. Okay, let's bring that closer to there. And then, what is wrong here? This should be, that should be tabbed in one. Thanks. Now it's more clear to me. I was getting a little confused by the indentation. Computer dot prototype dot update. I mean, really, and at this point, we're just like, you know what? I want to just play the game. Function needs to spelled right. Function. Oh, function was spelled right. I just can't spell anymore. Ball. We're just going to take the entire ball. We're going to use all of the ball because computers can cheat. Computers are cheating. So if it ever, like, you know, wins, then you can be like, oh, but it's cheating. Var x underscore position. That's what POS stands for, position, equals ball dot x, which is great. Let's use that. I like variables. Okay. We can also have a var difference, which is going to equal, okay, let's read this line of code really quick. This parenthesis, no, let's start with this parenthesis. So this dot paddle dot width divided by 2 plus this dot paddle dot x, okay, minus the x position of the ball is the difference. The difference. Yeah, okay, so that's, it's all like, hold on, that's kind of funny. If the ball is here and the paddle is over here, this gap is the difference. I don't know if you guys can see that. Hold on. Zoomy, focus. If that's the ball and that's the paddle, then this area right here is the difference. If the ball is over here, then this section is the difference. That's what that little bit of code is doing there, which is interesting piece of math. So var difference equals, let's just set it up here, minus, or, and then 2 parentheses, this dot paddle dot x plus parenthesis, whoop, there's a lot of nested parentheses, this dot paddle dot width divided by 2 minus x underscore position, which, I mean, is fine. If that's the only time we use x underscore position, though, and it is. Variables are a weird thing. I mean, I'm glad that we've used this variable here, the x position variable, but for just using it once, we could have just gone with ball x, but whatever, we're okay. So now we have a little if statement because we're going to check to see if we've got the max speed on the left and the right, and then this dot paddle dot move is going to do a difference. Oh, for the x. Okay. That'll work. So we've got a diff is less than 0 and diff is less than -4. Okay, so then we're going to go diff equals -5, which is apparently the max speed of -5. We're also going to do an else if, and over here we're probably going to be greater than 0 and greater than 4, and yeah, else if, so this is going to be diff is greater than 0, and diff is, hold up a second. Can I point something out? If difference is less than 0, that's one thing, and it can be true or it can be false. Let's assume that difference is not less than 0. Okay, let's just do that. That means difference is greater than 0. Let's just check here. Difference is, if difference is 1, is difference less than -4? It is not. Why are we even checking to see here? This doesn't, look, you know what? I'm just going to get rid of this bit of code right here. Diff less than 0 and diff less than -4. We don't need that. We just need it be less than -4. And over here as well, we don't need to know if it's greater than 0 and if it's greater than or if it's greater than 4. We can just say if it's greater than 4. I mean, it's okay. I'm going a little insane. I didn't make this tutorial. I mean, the thoughtbot.com people made a fantastic tutorial, and I am glad to be going through it. But just sometimes, like, I don't know, right? And so anyway, we're going to make our diff, and we're just going to set that one equal to 5, because if it's 5, it's 5, and it can't get more than 5 because that's the max. Okay, so there's our else if. Now we are going to this.paddle.move. And here we are, we're going to go with, and then the diff is basically how far we are going, how big or fast we are going. And then let's check this out. If paddle.x is less than 0, then make it 0. That's the left side. And if paddle is, there's the width, the height, the width of the screen again. That totally makes sense. Aren't we checking that in the move section though? Don't we check that in the move? Right side, stop moving, right? Right here. Yeah? Don't we check that? It looks like we checked that. We don't need to check this because we're checking it here, right? And this is the paddle. So I'm not going to put that in there. I feel like it won't go because it's checking it right here. So it says now that it's done. To see the code in action, we can hit the play button. So let's run it. Oh, sure. Let's break things. Oh, what did I do? Oh man. All right, hold on. It's not the end of the world. I mean, all of the beautiful pink thing left. That is kind of sad. But I'm sure that we can fix. I'm sure we can fix this. Let's. I don't want to go away. I'm gonna hold on. Control A. Copy it all. I'm gonna paste this somewhere safe. I'm gonna paste it in my notepad really quick. Paste. Okay, there. I've got it all saved in a notepad. You didn't see that. But I got it all. Now let's go back here. Let's I don't want to do that. Can I redo things? Edit redo? There's no edit redo. I've got it all saved though. Hold on. Let's go. There's my computer. Let's just paste in my new computer. It's the same computer that I had. What is this? What is this wrong? Why expected identifier? Oh, you know what? Let's see this. What is this? What's it yelling at me about? It is yelling at me because of what? Expected an identifier instead saw var. That's var. Oh, are you kidding me? Right there? Just a parenthesis? Oh, all right, run it. Okay, well, no, but, you know, that's got rid of all those little red dots. I got a new red dot, missing a semicolon. Expected an identifier and instead saw a closing parenthesis, expected an assignment or function call and instead saw an expression. So, okay, let's come up here really quick. Let's look at this function, computer.prototype.update. ball. Yeah, you know what? Let's do a thing. Let's cut and X, run. I got more scrolling, but I don't see any pink, so there's probably something wrong with that. This is my prototype paddle.move. We saw that before. Okay, so let's go a little bit further. X position, ball X, difference. This is, we're going to check to see matching parentheses. That's good. That's good. That's good. This is matching that one. This guy is matching that. This is matching that. That one is matching this down here. These match. Hold up a second. That doesn't match anything. Oh, I don't need it. Run it. Oh, okay, I had an extra parenthesis there. And we are, okay. So far, we're just set. This is really tall. I can barely see everything. Let's go here and smack it. He's moving up there. He stops. He's moving again. Ball's getting quicker. Ugh. He's moving. He's moving. He moves pretty quick too. He is moving. I'm moving faster. Well, the ball's moving faster. Ha! I won. And that, my friends, is what we're trying to do here. So I'm going to save this. Woo! Yeah, that's a lot of lines of code. That is 180-ish lines of code. There's some blank space in here. We're going to save that. It was 107 saves. That is my fiddle. I will be sharing that fiddle with you and a link to this YouTube video. And that only took us an hour and 45 minutes. I've disappeared myself. Where did I go? Oh, well, I've just closed the screen, and that's fine. That's fine. It's been a pleasure. I hope you all have a great day. Let me make this big. Bye now. Bye now. Like, it's great. I really hope you watch this in parts. Have a great day.